Is blindness a barrier? No.
Is deafness a barrier? No.
Are mobility, learning, cognitive disabilities, speech impairments and others, or even a combination of them, barriers? No way. Lack of accessibility is.
Welcome to Web Accessibility for All.
Follow the blind. This journey starts now.
Yeah, logged in fine. Screen reader worked great.
I've been pressing submit for 2 minutes. It just sits there.
It says loading, but it's been saying that since I poured my coffee.
Yeah, logged in fine. 0 issues.
Honestly, it was pretty easy. The screen reader read everything perfectly.
I use the keyboard because my mouse hand hurts, and I literally cannot get to the checkout button. I just gave up.
No problems here. I ordered my ticket in like 30 seconds.
The buttons are too small on my phone. I keep hitting cancel by mistake.
I filled out the whole form, hit enter, and the page just went blank. Did it go through? Who knows?
Works great for me. I use it every day.
10 people, same website, same WCAG compliance badge in the footer. 5 people are perfectly happy. 5 are completely blocked. Why? Because the real world doesn't care about your compliance certificate. Hello, my friend. Welcome back to Web Accessibility for All, the podcast where we bridge the gap between the WCAG standards and the messy, imperfect reality of the web. Today we are talking about a tool that most of you probably already have in your tech stack, but you are likely ignoring. It is called OpenTelemetry, and we are going to explore how this standard exposes the invisible walls blocking your users in real time.
Why WCAG compliance alone fails real users?
I know what you are thinking right now.
Wait a minute. We passed the audit. We even paid for user acceptance testing with disabled participants. Isn't that enough?
Uh-oh. Let me explain it this way. Imagine you are building a car. You run an audit that checks the blueprint. It says, yes, the car has brakes, seat belts, headlights. That is WCAG. It confirms the code is built correctly. Now, user acceptance testing, or UAT, that is the test drive. A sunny day, a smooth road, and a professional driver. It shows that the car can work. So, audits check the code, and UAT checks the happy path. But there is a problem. The web is not a sunny day. The web is a rainstorm. Neither can observe the chaos of real life at scale.
OpenTelemetry explained, the missing accessibility tool.
Now, if you ask a DevOps engineer about OpenTelemetry, they won't talk about accessibility. To them, this is a tool for the cloud. It's originally about server health. But here is the secret. That same standard also happens to start right inside the user's browser. OpenTelemetry is a global, vendor-neutral standard maintained by the Cloud Native Computing Foundation that acts like a shared language for how systems describe what actually happened. Basically, OpenTelemetry is a framework that handles the heavy lifting for monitoring. It takes care of your traces, metrics, and logs. from generation all the way to export. It just gives you a standard way to collect and process that data.
Full stack observability versus front-end accessibility.
Most of our current tools, screen readers, scanners, audit scripts, observe the interface layer in isolation. They only look at the browser, but we know that accessibility failures often emerge between layers. The server is slow, database errors out, the API sends the wrong data.
How to implement OpenTelemetry.
Okay, let's talk about what actually happens in the browser when you hook this app.
What does the data actually look like?
It's just a JSON object called a span. Think of it like a shipping label. It has a trace ID, the global tracking number for the whole user journey. It has a span ID, the specific step the user has took. It has a timestamp, a duration and a status code. And crucially, it has attributes. These are key value pairs where you can add context, like
component, checkout button,
or
version 2.5.
How does the library work?
This is the piece most people miss. How does the server know that the specific request came from a specific user? It uses something called context propagation. When the browser sends a request, OpenTelemetry Hotel injects a tiny header called trace parent. If the connection drops, we know exactly where it failed.
But if I track every click, will it slow down my app?
No, because OpenTelemetry is smart. It collects those shipping labels in a buffer and sends them in a bundle every few seconds off the main thread.
What happens if the user loses connection?
It tries to keep that buffer in memory. When the network comes back, it flashes the data.
And if the user closes the tab?
Modern Auto uses the browser's beacon API. It essentially screams the last few seconds of data to the server as your tab is dying, so you don't lose that critical crash moment.
How do you actually do this in your web app?
OpenTelemetry has what we call auto-instrumentation packages. Once you initialize it, it automatically hooks into the fetched requests, document load events, and user interactions. It just sits there, watching and reporting. Now we need to pause here, because once some engineers realize they can track the user's journey in this much detail, they almost always ask the same question.
Wait, if we can see the browser context, can we see who is using a screen reader? Can we get a list of our blind users?
Can you detect screen readers?
The answer is no, and the answer must be no. First, because it's technically unreliable. Browser vendors block that kind of fingerprinting on purpose to protect user privacy. But more importantly, it is ethically wrong. You do not have the right to know a user medical history or disability status just because they visited your website. That's a violation of trust.
So, are we stuck? If we can't see who is disabled, how do we find the barriers they face?
We flip the script. We stop trying to track identities and we start tracking signals. We don't care who the user is. We care about how they have configured their world. And the browser gives us these signals explicitly.
OS preferences.
Does the user have prefers reduce motion turned on? Does the user have high contrast mode enabled? These aren't secrets. The browser broadcasts them so your CSS can react.
Input behaviors.
We aren't looking for screen reader users. We are looking for keyboard-only sessions. We can see if a session has 0 mouse movement but hundreds of tab and enter key presses. Do you see the difference? We are not building a list of disabled people. We are building a heat map of friction. We are asking,
do users with reduced motion settings experience slower load times than everyone else? Do keyboard-only users get stuck on the checkout page 50% more often than mouse users?
3 metrics that reveal invisible accessibility barriers.
here are the 3 specific patterns that reveal invisible accessibility barriers.
Vital sign number 1, the rage click and the dead end.
We've all done this. You clicked a button, nothing happens. So you click it 5 more times. That's a rage click. But here is the accessibility twist. Filter your data for keyboard users. If you see a user hitting the Enter key 10 times in a specific button, you don't need to guess what happened. You just found a blocking bug without opening a code editor.
Vital sign number 2, the JavaScript gap.
This one is the silent killer. Remember, OpenTelemetry watches the whole race. Sometimes the server says,
I sent the page, 200 OK.
But the browser never starts the next lap. What does that mean? It means the HTML arrived, but the JavaScript crashed. To a user on an old Android phone or someone using strict security settings, that is a blank white screen.
Vital sign number 3, performance is panic.
We usually talk about site speed. I want you to think of it as cognitive accessibility issue. Look at your users who have the reduced motion preference turned on. These are users telling you,
I need a calm, steady experience.
Now look at your layout shift metrics for just those users. If their version of the site is jumping around while it loads because of slow ads or big images, you are actively causing the anxiety they asked you to prevent.
From audits to observability.
Let's go back to the beginning. Remember those 5 people who were blocked? If you only look at your audit report, those 5 people don't exist. They are just edge cases. They are just statistical noise. But if you look at the telemetry, they are right there. They are the signal in the noise. They are telling you exactly where your product is breaking. So here is my challenge for you. If you are a developer, go and look at your login tools. Are you catching errors in your UI? Or are you just letting them fail silently? If you are a specialist, go talk to your DevOps team. Stop asking for audit reports. Ask to see the error rate by input type. Ask them,
do we know if our keyboard users are crashing more than our mouse users?
Pick one critical flow, instrument it, watch it for a week. Because at the end of the day, an audit can only tell you if your app is accessible in theory. But tools like OpenTelemetry, they tell you whether accessibility actually survives contact with reality. Thanks for being part of Web Accessibility for All. Remember, behind every data point is a real person trying to use what you build. Let's make sure we are listening to them. Goodbye.
Thanks for joining us today. Subscribe for a new challenge next week. And don't be shy. Leave us a review or ask your accessibility questions online. See you next week for another episode of Web Accessibility for All.